All right, so on Monday we talked about correlation, and for correlation we use the letter R. R describes the correlation of a sample, and we use the Greek letter rho to represent the correlation of a population. So we take a sample, we know that the correlation of that sample will be close to the correlation of the population, but it's not going to be perfect, okay? So when we do hypotheses, so the test we're going to do is going to be a t-test for correlation, and when we do that t-test for correlation, if our question is about correlation, our hypotheses will be about will be about rho. Okay, so for example, if I say, is this evidence of a positive correlation, that would be that the correlation rho is greater than 0. My alternative would be less than or equal to 0. So if we're trying to decide a positive correlation, right, that's what we would have. If I'm asking, is this evidence of a negative correlation, my alternative would be rho is less than 0 versus rho is greater than or equal to 0. Is this proof of any correlation? My alternative would be not equal to 0, and my null would be equal to 0. Okay, so there is a formula to calculate t. You will not use this formula. I don't even know if it's on your formula sheet, but I'm telling you right now, your calculator will do all of it for you. So don't stress about the formula. The part that I do want to highlight is that when we're doing t-tests for correlation, our degrees of freedom is not n-1, it is n-2. So this is going to be similar to every other test. I'm going to spend a lot of time today talking about what are my expectations, because there were definitely some issues with you guys not understanding my expectations on the previous test with respect to hypothesis tests. So I want to make sure we all understand everything I would expect to see, okay? But you write your hypotheses, you sketch your sampling distribution and label your rejection region, okay? And that's by far where we had the most issues. Then you get your test statistic and p-value, and then you make your conclusion, okay? So let's look at an example. Those of you who were here, and this is on Monday, if you were here on Monday, you already have this list in your calculator. If not, you need to put the years in your L1 and the prices in your L2. I'm going to give you guys a few seconds to get that because we'll need to do that. Okay. All right. All right. So when you watch the video on, if you haven't yet, when you watch that video, I'll take you through how to come up with a scatter plot. When we look at, that's not the right scatter plot anyway, I don't think. All right, so here's our scatter plot. When you guys look at the scatter plot, do you think there's going to be a correlation? Does it look like there's a relationship between the year of the car and the price of the car? Is everybody good? Okay, so what we have to decide is this relationship that we're seeing here, is it a strong enough relationship that we don't think it only applies to this sample? Like, can we broaden it out to talk about everything? Okay, is that relationship by chance for this sample? So let's look and see how that looks, okay? All right, the wording of the question says, use the data to determine if there is a significant correlation. Is it asking me about a positive correlation or a negative correlation? Okay, what would the value of rho be if there is a correlation? I can tell you it's anything but 0, okay? Rho equals 0 means there's no correlation. Rho being positive means there's a positive correlation. Rho being negative means there's a negative correlation, okay? So as I'm going to write my hypotheses here, my null is going to be rho equals 0. My alternative is going to be rho is not equal to 0. All right, in the part I have labeled critical value, this is the part on the last test that is a 6-point question that there's very clearly, you guys either don't know how to do it or don't understand my expectations. So I'm going to show you this, show you how to calculate it. Then I'm going to say, here's what I would look for while I'm grading it. And if you don't have this, it's not good enough. It doesn't have all the necessary qualities, okay? All right, so anything with correlation, the picture is a T, okay? Correlation always goes with T. Okay. So I am going to, first thing I'm going to look for on your graph is, do you have it labeled with a Z or T? When it's correlation, this is going to be a T. But sometimes when it's means, we have a Z. And for proportions, we always have a Z. Okay? So I will be looking for that, and that, do you have it centered at 0? Okay. Next. You have to decide, based on our hypotheses, is this right-tailed, left-tailed, or two-tailed? Two-tailed, because not equal to could be greater than or less than. Okay, great. So I want to see two tails that are shaded. I want to see what is the area of those two tails. I want to see what are these boundaries. So, what are we going to do? How do we find it? Inverse T. When I go to use that inverse T, it's going to remind me one more thing. I need to write down my degrees of freedom. What are my degrees of freedom in this case? My sample size is 9. So my degrees of freedom is 7 because, as we said on the previous page, for correlation, it's n minus 2. Now I can do my inverse t. A reminder, inverse t only deals in left-hand areas. So I'm going to put the point 0.025, my degrees of freedom. And they're symmetrical, so we can put them both in. Okay. So, to put you guys in the mindset of Miss Meister on Wednesday when I'm grading your tests, okay? When I go to this part, I'm going to look at this. Hold on. Put it in red. Do you have this, these two things combined, these combined, and do you have the shading? All of those things I'm going to be looking for. Because this picture is where all of our decisions are made. So we need to have this picture. Everybody good? All right. Now to get our test statistic and or p-value, we're going to use the exact same menu we have been using to find test statistics and p-values. So we're going to hit stat, we're going to arrow over to tests. And you want to pick the one that applies to linear regression. So you're going to pick linear regression t-test. It's the very last ones. You guys, if you know that you are doing something with linear regression, lines, and we could tell from that scatter plot that's a line question. Let's say I forget that this is a t. Do you guys see that the calculator is also telling you it's a t to help you go back? That's a way that the calculator menu will tell you which one to pick. Kind of. Okay. So go ahead and pick linear regression t-test. What you're going to want to do is make sure your X list is L1, your Y list is your L2. You're going to make your alternative hypothesis match. So you're going to select the not equal to. Yeah, just leave that blank. So, you guys, I'm getting a t statistic of 6.842. My p-value, yours I think comes back in scientific notation.
2.4369.
Yeah, so times 10 to the negative fourth.
Yep.
Or, I'm just short, sorry. Right here. Yeah. Mine, like, I do not care. 2.43. So that would run to 2.44. I don't care if it's in scientific notation versus standard notation at all. I would have a problem with you giving me, like, the p-value is essentially the probability this sample could happen if there's no correlation, which is like pretty much, if there's not a correlation between these two things, this sample shouldn't happen, okay? Which is, again, evidence that there is a correlation, okay? I would have a problem if you just gave me the 2.44. That would be problematic because your p-value can never be bigger than 1. That would be very problematic for me because it's a probability. All right, questions? All right, you guys. What can we say about 6.842 with respect to our graph? It's in the rejection region, yeah? Every good? What about 0.00024? That's less than 0.05. Both of these suggest that we are going to reject. And what are we rejecting? We're rejecting HO. Okay? All right. You guys, your conclusion is always going to start with however many, in this case we're using 5% significance. We can say and steal the wording from the question. Though if you wanted to, this one we might narrow down a little bit, okay? But we can say there is a significant linear correlation this should be an example of where you guys tend to leave your answers. Okay? The whole idea is we're talking about an actual context. So maybe between model year and selling price. Tell me a little bit more of the story. Okay? Lastly, to get the equation of the line, y hat. Okay? So you guys, the equation of our lines is going to be similar to y equals mx plus b. All your equations need to have a hat on it. That'll be explained in the recording. And then you notice how it says up here y equals a plus bx? And then it gives you values for a and b. So that's how you write you use those values to write the equation of your line. So in this case, y hat would equal negative 1867280.95 plus 935.71x. I'm sorry?
For labs and homework, are we working on that?
I spent the first 5 minutes of class explaining that. We're going to have time today to work on the homework. We're going to have the first half of class on Friday to work the lab. And then I'm specifically choosing some examples that I know you guys tend to struggle with to review for the test for the second half on Friday. All right, let's look at another one. Let's go ahead. As soon as you guys see this, I would want to put this in your L1 and L2. Yeah, so hit stat, and when you hit option number 5, it says setup editor. Just hit it. It's going to say done, but now when you go back, it'll still be there.
Okay. Cool.
Okay, so as you guys are finishing up, I just want to kind of putting these in. Let's talk about what we might expect for these two variables, okay? So if there's, like, think about what you guys know about supply and demand, right? We don't need to, I'm not an economist. In fact, I've never taken one in a single economics class, okay? But when you have a large supply, demand is low, yeah? Because you have a plenty of supply. So what does that do to prices? Drops them, okay? And then likewise, when the supply is low and there's not very many, prices are going to go up. Okay? So as we look at these, like, it's hard to tell from just this list of numbers, but what would we expect to see if there's in the prices if there's a lot of homes on the market? High prices or low prices? Low. So as the number of homes on the market is going up, the prices are getting lower. Is everybody with me? So we might expect to see a negative relationship. And in fact, if I bring up this scatter plot, it in fact does look like a negative relationship, yeah? Is everybody okay? All right. Now, the question is asking us, use the data to determine if there is a significant negative linear relationship. What would that say about my alternative hypothesis if I want to show a negative relationship? Rho is less than 0. My alternative would be rho is greater than or equal to 0. I'm sorry. Okay, because this is where I am concerned about you guys moving forward. I want you guys to draw the picture with all the labels and stuff on it for this one. And then you're going to grade your own picture. You guys see what I'm saying? To see what is it I'm likely to forget in this picture that Meister's requiring of me. Because again, this is where I see the biggest gaps in where in my expectations versus what you guys are giving me. Okay? So you guys are doing this part on your own, and then we're checking against me, what I have. right, so compare your picture to mine. The first thing I would look for is, did you tell me that it was a T-graph? Are you centered at 0? Did you shade to the left?
When you shade the left, it's based off the alternative.
Mm-hmm.
Okay.
Did you label the area that you shaded? Did you label your degrees of freedom? Think of it this way, you guys. You'll see next to this part of the question, I'm pretty sure this part is worth 6 points. If you just sketch this, which is what a lot of you put on the last test, that's not 6 points worth of work. Do you guys get what I'm saying there? Okay. And this picture is such a huge part of our decision-making process. To not draw it well is a problem. Okay? All right. Next, can you guys find me the test statistic and p-value? I can't remember if I put that wording there or not. This one, these are kind of weird because it's not like, these rarely have like someone's claiming there's this versus.
I didn't know because like that one it said there is a significant negative linear correlation, so it would definitely be alternativeness, but I don't know if it matters or not.
How are we doing on getting the calculations here? Okay. Tell me about this t equals negative 4.888. In the rejection region. What about my p-value?
It's less than 0.
This is less than 0.01. All of those, both of those things combined definitely tell me I'm going to reject my null hypothesis. Lovely. Talk me through my conclusion then. Again, use your whatever I give you, right? So in this case, at 1% significance, we can say there is a significant negative correlation. Between number of homes on the market and average selling price. Yep.
So like when you are like choosing which hypothesis to go with, so it's like the one that gives you the question, is that going to be like your alternative?
Most of the time, yeah, because like the one in the question is going to be, is there a correlation? Is there a negative correlation? It would be the strictly less than or strictly greater than. And it'll always be zero, right? Negative, it just, like in reality, numerically, negative means less than zero, strictly less than zero. So the one in the, and for this particular one, because whatever's given in the question is either going to be not equal to zero, positive means strictly greater than zero. Like the equal to will always be in the null based on the way these ones are worded. That's not true in other ones, obviously.
Like what I'm asking is like, so like when it's what, like when you're saying that the level of significance correlation between the number of homes in the market and average selling price, like how do you know that goes with like the alternative?
Well, the alternative is just that they're negative, yeah? Like, this is what the alternative is. I rejected the null. Like, how do I know it's negative? Because I just rejected this one and said that this one was true. So that tells me that the negative is correct. That it is a negative correlation. And then how do I know between the two variables? It is, these are my two variables. That's it. Like, that's how you pick the between. All right, last thing, guys, can you give me the equation of the line? $244,625 and some change minus 1,096.40 x. Are we good? For this last part, we just got to real quick talk about, this is like a very specific study. This one's just like, you got to study it. Okay? But I got a picture to kind of show, I got a couple pictures to show kind of what I mean here. Put that in there. Bothering me. There we go. All right. So, to give you some perspective of what this picture is. Okay. This horizontal line right here is the mean of the selling prices of these homes. Okay. And so, what you'll notice is like for each one of these, so for each dot, there's a vertical distance. And what does this distance kind of really mean? This distance is describing kind of how far how spread out the selling prices are. Okay? It's in some respects relates back to the standard deviation of these selling prices. Okay? Is everybody with me so far? And this horizontal line that I'm comparing it to right now is just the average of the y places, right? So the x coordinates on this mean absolutely nothing. Is everybody with me so far? Okay. So this other picture, this picture is the line of best fit. And so the minute I draw in that line says, hey, this is how the x's and the y's are related to each other. So all of a sudden it's kind of like it's taking the x values, the number of homes on the market, into account. And so if I draw the same set of vertical lines, what are you noticing about pretty much every single one of these lines comparatively to the purple versions of them? It's a lot shorter. Does that make sense? Okay, so are you guys with me that the points are closer to the line that has x in account than the line that has no x's in account? Okay, that's, so like, taking those x's into account is allowing the x coordinate to explain why the y coordinates are why they are. Okay? It's saying, hey, of course these ones are low, a lot lower than the mean. Of course they're lower than the mean because there's a lot of houses on the market for those ones, for those points. So it makes sense that they would be cheaper houses. Okay? All right, so it's letting the homes on the market explain those differences in the y's. Everybody good? Okay. So when we talk about, we've talked about R squared is just, we call it the coefficient of determination. So clarification, R is our correlation coefficient. R squared is the coefficient of determination. There is a very specific interpretation for R squared. So as I'm looking at this one, we can get from the calculator here, do you guys see that from running that regression equation, all that kind of stuff? We've got that R squared equals 0.749. Is everybody good? For this particular set, okay? Here's how that interpretation goes. You're going to turn that R squared into a percent by moving the decimal point over 2. Like at this point, you guys should be pretty old hands at turning decimals into percents, right? So you're going to say 74.9% of the variability in, right now I'm just going to put a blank, can be explained by the linear relationship with blank. Okay. And what we're doing is we're allowing the x variable to explain what's happening to the y variable. Why do we have sometimes low prices and sometimes high prices? Kind of the relationship with how many homes are in the market. Okay. All right. So 74.9% in the variability in average sale price. So that first blank is always going to be filled by your y variable. Can be explained by the linear relationship with, that second blank will always be your x variable. The number of homes on the market. Okay.